For this first set of problems, we should be working on the innermost function first and then going out from there. So for part A, for number 1, f of g of 4. So, all right, what is g of 4? G of 4 is equal to 3 times 16 plus 1, so 49. So then we want f of 49. F of 49, 2 times 49 would be 98. For part B, g of f of 2. So start with f of 2. F of 2 is equal to 2 times 2, 4. And then the outer function is g, so now find g of 4. 3 times 16 plus 1 is 49. F of 1, start with f. F of 1 is equal to 2. So now instead of f of 1, f of 2. F of 2 is 2 times 2, so that answer is 4. Okay, so we do that for each one. So part A, for number 2, we start with g of 4. That's 3 minus 1/2 times 4 squared is 16. 3 minus 8 is negative 5. And then it's f of negative 5. That's 4 times 25 minus 3. So 100 minus 3 is 97. G of f of 2, start with f of 2. 4 times 4 is 16, minus 3 is 13. And then g of that answer, which is 13. 3 minus 1/2 times 13 squared. So 3 is going to be 6 over 2 minus 169 over 2. That's negative 163 over 2. And I would just leave it like that. There's no reason to make it a mixed number. For C, f of 1. So start with f of 1. 4 minus 3 is 1. The result is f of 1 again. 4 minus 3 is 1. For number 3, f of g of 4. So what's g of 4? G of 4 is 2 times 4, which is 8. F of 8 is radical 8. We would make that 2 radical 2. For part B, start with f of 2. That's the innermost function. That's square root of 2. And then g of that answer, g of radical 2, is equal to 2 radical 2, because it's 2 times x. And for part C, f of 1, square root of 1 is 1. F of 1, square root of 1 is 1. For number 4, g of 4 is 1 over 16 plus 1, 1 over 17. F of 1 over 17 is the absolute value of 1 over 17, so it's also just 1 over 17. Part B, start with f of 2. Absolute value of 2 is 2. Plug that into g. G of 2 is equal to 1 over 4 plus 1, 1 over 5. Part C, start with f of 1. Absolute value of 1 is 1. Plug that answer into f. F of 1 again is 1. It's weird that that keeps happening, but it does. All right, number 5. So in number 5, we have A starts with g of 4. So put 4 into g, you get cube root of 4, which doesn't simplify because 4 is only 2 squared. and then plug that into f of the cube root of 4. So that's 3 over the cube root of 4 plus 1. Now, we don't have an easy way to rationalize the cube root of 4 plus 1. If it were just the cube root of 4 by itself, you could rationalize, but the plus 1, like conjugates are not going to work. So let's just leave this one unrationalized. Okay, for b, we start with f of 2. When you plug 2 in, you get 3 over 3, which is 1. And then find g of that answer, so g of 1. Cube root of 1 is 1. And final one in this section, f of 1 is 3 over 2. F of that answer is 3 over 2 plus 1. That's 3 over 2 plus 2 over 2. That's 3 times 2 over 5. That's 6 over 5. All right. For the functions f and g in problem find f of g of negative 1 and g of f of negative 1. Okay, so starting with this first one, g of negative 1, again for function 5, is cube root of negative 1. And then f of that answer is equal to 3 over negative 1 plus 1. That's 3 over 0. So f of g of negative 1 is not defined. Even though negative 1 was able to be plugged into g, the result, negative 1, is not able to be plugged into f. That doesn't mean that the composition the other way doesn't work, but we can double check. Start here, f of negative 1, but we do run into the same problem. 3 over 0, undefined. So if you can't even plug in the innermost part, that means that g of f of negative 1 also doesn't exist. We talked about domains of composition functions, and the innermost domain has to be satisfied as well as the final result. So this is sort of an example of that. Number 7, if f of x equals this and g of x equals this, find f of g of 1 and g of f of negative 2. So f of g of negative 1, start with g of negative 1. That's negative 3. And then f of that answer, square root of negative 3 plus 1. So it's the square root of negative 2, which is not real. We haven't talked about imaginary numbers officially yet. We will be doing that in chapter 2. So for now, you could say not real. If you want to simplify that, it's I radical 2, but I would take either one. Okay, and then what about the other one, f of negative 2? So f of negative 2, square root of negative 2 plus 1 is the square root of negative 1. Again, that's I, but that just means that there's no real solution. So for both of these, there's no real solution that you get out of those two values. All right, we've seen some tables in our AP problems. So here's another table. It's a little nicer to have them on paper, I think. Complete the table below given that f of x is an even function. Remember, that means that f of negative x should equal whatever f of x equals. So let's look at f. If f of negative 3 is 0, then f of positive 3 should be also 0. If f of negative 2 is 2, f of 2 should be 2. And f of 1 and negative 1 should be the same as well. G of x is an odd function, so that means that the g of negative x should equal negative g of x. Okay, so here's what that means. I've got it kind of switched around. It also could mean negative g of x. Negative g of negative x equals g of x to kind of match what we have, but all this is saying is g of negative 3 is 0, so g of 3 would be the opposite of 0, which is still 0. G of negative 2 is positive 2, so g of positive 2 has to be negative 2. And g of negative 1 is positive 2, so g of positive 1 has to be negative 2. So opposite signs. Okay, and then for h, that's the composition where h is g of f of x. So to figure out h, it would be best to do probably a little table here. So h of x is equal to g of f of x. Start with your x value -3. H of -3 is equal to g of f of -3. That's g of, what is f of -3? So when x is -3, f is 0. What's g of 0? When x is 0, g is 0. That means h of -3 is 0. And we do that for each one. Okay, so then we're going to say -2. H of -2 is g of f of -2. What's f of -2? +2. What's g of 2? Go to 2 for x, go down to g. That answer is -2. So, excuse me, h of -2 is -2. If we plug in -1, h of -1 is g of f of -1. F of -1 is 2. So now it's g of 2. G of 2 is -2. So when we plug -1 into h, we should get -2. If we do this for the zeros, I kind of ran out of room there. I can squeeze it in. H of 0 is g of f of 0. F, when x is 0, f is 0. When x is 0, g is 0. Plug it in for 1. H of 1 is equal to g of f of 1. When x is 1, f is 2. When x is 2, g is -2. Plug in 2. So when x is 2, f is 2. When x is 2, g is -2. And finish it off with 3. H of 3 equals g of f of 3. What's f of 3? When x is 3, f is 0. When x is 0, g is 0. So h of 3 is 0. This is pretty common, getting a table on an AP question and having to evaluate maybe not all of these numbers, but pull out a couple of these and be able to figure out what's happening. Okay, this one's a little shorter because we only have 3 things to do. H of x is g of f of x. Okay, so same idea. If I want h of 0, that's g of f of 0. When x is 0, f is 1. So really this is just g of 1. When x is 1, g is 0. Therefore, h of 0 is 0. Okay, do it for next one. Just going to bring this work over here. H of 1 equals g of f of 1. When x is 1, f is 2. So this is now g of 2. When x is 2, g is 5. So h of 1 is 5. And my third one, I want h of 2. That's g of f of 2. When the input's 2, f's output is 0. When g's input is 0, its output is 2. Okay, that finishes our first page. Use the figure to estimate each of the following. So your best guess on these, I'm going to kind of use decimals as best as I can. So start on the innermost function, g of 2. So that means go to 2 on the x-axis. And where does the graph hit g? G is this lower one. So let's estimate. This is 1.5. I'm just going to call this 1.7 or 1.7 I think is fine. So now I'm at f of 1.7. Go to 1.7 again. Here's 1.5, so go to like 1.7-ish and see where you hit the graph of f. What will we estimate that to be? It's pretty close to 4, maybe like 3.8. If you're somewhere in there, 3.8, 3.7, something like that, should be good. Start at f of 2. So when the input is 2, where do we hit f? It's not quite 3.5. I'm going to call it 3.4. So that's g of 3.4. Now go to 3.4. So here's 3.5, a little bit short of that. Where does the graph hit g? A little bit above 1, not quite 1.5. I'm going to call it about 1.2. Go to 3. Where does the graph hit f? Just below 2. I'm going to call that 1.9. Go to 1.9, so just before 2 on the x-axis. Where does the graph hit f? Just above 3.5, or maybe it is 3.5. I'll just call it 3.5. Okay, last one, g of 3. Where do we hit g when we're at 3? A little higher than whatever I said for this. I said this was 1.2, so I'm going to call this, I'll call this 1.3. Go to 1.3, and where does the graph hit g again? So maybe like right here. It's a little bit above 2, not quite 2.5. I'll call it 2.3. You might say 2.25. That's fine too. Okay? All right. For the next set of problems. Now let's see if we can get some graphs based off of this stuff. Now, here's one thing. These graphs aren't labeled, and they should be. So see how these are numbered and labeled? Right? There is supposed to be like an X and a Y axis in here, and it's just kind of hard to see. So you might want to take your pencil and just go over this a little bit thicker. Where the lines through 0, 0 go. Maybe the same thing here. And I'm going to zoom mine out a little bit so that I can see the graphs and make a table of points. Now, I am a person who cannot keep track of too many numbers in my head, so some of you might be able to do this without writing a ton down, but I would suggest writing things for the first few. All right, so what am I talking about? Basically, I would like to make an XY chart for every single one of these. And the X values that we need to plug in range from -2 to +2, right? And again, the numbers are weird. We're used to seeing those numbers here. So just know they're just labeled at the bottom, but this is the X and Y axis. Okay, so we're going to plug in -2 to +2 into, for the first one, f of g of x. So the same way I did the last few problems, f of g of -2. That means f of what? What is g of -2? So here's g's graph. At x equals -2, the graph is about here. Let's call that -0.7. What is f of -0.7? So go to -0.7. So that's about here on f's graph. And where do we think that hits? It hits at about 0. So for my first point, I'm plotting the point -2, 0. Right there. Okay, repeat that for -1. f of g of -1. What's g of -1? So here's -1 on the x-axis. We hit, it looks like that's -1. So now we're doing f of -1. Go to -1 on f's graph. And where are we now? When x is -1, the graph is, I'll call that -0.2. So this point, -1, -0.2, will be about here. F of g of 0. What does that mean? F of what? So what's g of 0? So when x is 0, where do we hit on the g graph? I'm going to call that the same height here. I'm going to say that's -0.7. And you can save yourself a little bit of work if you trust your first answer back here. I already said f of -0.7 is 0. So I can plot a point at 0, 0. Okay, f of g of 1, that means f of what? So go to 1. Now we're up here. I would probably call that, oh, I don't know, how high up are we? Maybe 0.3? Maybe it's 0.2, I don't know. Maybe it's 0.2. Does it matter, 0.3 versus 0.2? Not really. All right, and then what's f of 0.2? So go to positive 0.2 and see where you hit the graph. Maybe that's 0.8. Okay, so I'm going to call that 0.8. So I can plot the point 1, 0.8. Maybe like there. And finally, f of g of 2 is f of, so g of 2. Where do we hit the graph on g at 2? It looks like we hit right at 2. So that'll be f of 2. Go to 2 on f's graph. And I think that's just about the same. If it's not 0.8, it's maybe 0.7. I'm just going to call it 0.8. Maybe I'll call it 0.7 because I don't want it to be the same height. Okay, so let me just double check on that. Yeah, so when we were at 2, yeah, I guess that's a little bit lower than the other point I marked as 0.8, so we'll call it 0.7. So we can plot 2 and then just a little bit lower, 0.7. I would connect this with a smooth curve because the graphs of f and g are smooth curves, so their composition should also be smooth. All right, so it's a little tedious, but you can see that's kind of how we're going to go through each one. And it would be hard for me to just, some people can just like plot their pencil all over the place and go from there, and I just can't. So if that's you, that's awesome. I'm erasing my old marks. I can do that easily with my computer. You might have to get out your big white eraser if your marks are going to mess with you. What if we switch it to g of f? So, g of f of x. You're plugging in the same x values and doing the same type of thing, but now we're going to start with f's graph. So start at f of -2. So when x is -2, f is at -2. That means we're really looking at g of -2. At -2, where does g's graph hit? Maybe -0.7 again. Right, so I can plot this point at -2, -0.7, kind of there. And my next one, g of f of -1. So that's g of, what's f of -1? Let's see. F of -1 is here. And so then, what are we going to call that? Maybe we'll call that -0.2. So now we're doing g of -0.2. Go to -0.2, so that's just to the left of 0, and see where you hit the graph of g. It's just a little lower than -0.7, but closer to -1, so maybe that's -0.8. So I'll go a little bit lower at -1. I'll just be a little bit closer to -1. Okay, and then 0, g of f of 0. What is f of 0? F of 0 is, let's call that 0.7. G of 0.7 is just about 0. So we can plot a point at 0, 0. Okay, and then if we're going g of f of 1, that's g of what? Let's see, f of 1. F of 1 looks like it's exactly 1. That's always nice. G of 1 looks like it's, oh, I don't know, 0.2. So I can plot 1 and then go up about 0.2. And final one on this graph, g of f of 2. That's g of, what's f of 2? F of 2, let's call that 0.7 again. And we said earlier, 2 lines ago, we said g of 0.7 is 0. So again, connected with a smooth curve, we have something like that. Those are my first two graphs. And then what if we do f composed with f and g composed with g? So, all right, now my work kind of carried over a little bit too far, so I'm going to try to scooch a little bit. That erased some of my work, but actually, no, I don't want to do that. I want to undo. Oh, Lord. Okay, I want to undo that. And, oh no, I guess I didn't undo that. Well, anyway, I'm just going to get these numbers out of the way. Okay, so let's do this in green. So, same idea. F of x. Same x values between -2 and 2. F of -2. What is f of -2? Let's get these blue dots out of here. Some of them anyway. Okay, so I'm only going to be on f's graph. F of -2 is -2. That means I'm looking at f of -2 again, and I'm getting -2. So I can plot -2, -2. F of -1 means f of what? So when we go to -1 on f's graph, we're at about -0.2, I would say. So now we're looking at f of -0.2, and we're about here somewhere. Maybe that's about -0.5. Okay, so when I'm at -1, I can go down -0.5. F of 0. What is f of 0? F of 0 is about, what have I said before for f of 0? Looks like I said 0.7. I think that's about right. And then what's f of 0.7? So if I'm at 0.7, I'm just below 1. I'm maybe at like 0.9. Okay, so I can go 0.9, so just below 1. And if I go to, let's see, if I go to 1, what's f of 1? F of 1 is 1. So that becomes f of 1 again, which we said was 1. And f of 2. What's f of 2? F of 2 is about, what have I been calling that? About 0.7, I think. It's about the same as f of 0. And we said f of 0.7 was about 0.9 is what I said earlier. So this is kind of a weird, this one's a little weird the way I have it plotted. Maybe my point could be moved up a little bit. It's kind of a strange one. Okay, and then this last one, x, when we get g of x, going from -2 to +2. G of -2 is g of what? So for g, get my blue marks off of here. Okay, so for g, When we're at -2, G's graph is at about -0.7. And if I go to G of -0.7, where do we hit the graph? Pretty close to 1, -1, maybe like -0.9. So at -2, I should be at about -0.9. Right? And then at -1, when we're at -1, G is at -1. And G of -1, again, is -1. So at -1, we're at -1. G of 0. At 0, G's graph hits about -0.7 again. So that's going to be about -0.9, like it was before. G of 1. When we hit 1, G's graph is at about 0.3 maybe. When we go to 0.3, G's graph is 0.5, -0.5. So when we're at 1, we're at about -0.5. And last one on this page, G of 2. When you're at 2, G is at 2. And again, when you're at 2, G is at 2. So we can plot 2, 2. This one's sort of a strange thing going like that. All right, that's the first 2 pages of this packet. If you'd like a video for the last 2 pages, it should be the next video.